Hello, welcome to the project introduction of my dissertation. The title is Virtual Museum with Augmented Reality. This project aims to build an AR workflow for museums to easily implement AR in their online exhibitions and virtual museum. This workflow has three parts: a mobile app for data capture, a desktop app to process data into 3D models, and a website to show how AR can be implemented. First, let's set some boundaries. The project does not aim to produce digital replicas that museums use to archive their relics. Materials like glasses and mirrors are unsuitable for this workflow. With that out of the way, let's take a look at this workflow. The mobile app is used to take a series of orbiting photos, while also gather other sensor data, which helps to identify size and orientation. Here are some key features of the mobile app. Now, let's see it in action.
Welcome to the mobile app. On the top left corner, you can see the details of this capture. There are recommended capture sizes, the quality of your photos, and other sensor data. On the top right corner, there's a helpful guide for best practices. And on the bottom right, there's an auto capture feature. It's best to use with a turning table.
The desktop app uses CPU, GPU, and NPU, also known as AI acceleration hardware, to produce better quality model compared to mobile devices. Even though users can post-process their models for better result, there's no hard limit or require for modeling experience. Let's see how it works. Welcome to the desktop app. So here is the app itself. In here, you select the data and photos from the capture software. As you can see, there's the photo, the gravity information, and the depth data. And you select your output folder and how fine you want the detail. For mobile users like websites or apps, it's recommended to use reduced or medium to reduce their file size and lower the transfer time. And you can order, if you order these photos, you can select unordered or sequential to maybe speed up the computation a little bit. And the sensitivity is for if you have fine details, you can set it to high. Otherwise, it's recommended to keep it normal. And for models that are like this teapot you just saw in the mobile app, it takes around 2 minutes to calculate. And this is the direct output of those data. So you can see the detail is pretty good. Since this workflow uses USDZ file format, it is natively supported by Apple devices. Therefore, it's stunningly easy to include these models in websites and apps. Additionally, users can add animation, audio, and much more using other free tools, like Reality Composer or Blender. Let's see in action.
Welcome to the website. So here is a simplified representation of an online exhibition. You can see all the relics over here. And if you go into more, you can see on the top right corner of this photo, there's a AR symbol. If you click on that, after the model loads, you can put in your real life. You can resize it, rotate it, or even move it. And scrolling down, you can see the introduction of this exhibit and other exhibits as well. Here's a Dombu kettle. And further down in this website, you can see some limitations and challenges, which are some models with hair, transparent, or hard to scan surfaces.
Here are the references. Thank you very much for coming to this introduction. I hope to see you in the interview soon.